picture this thing. Okay. Probably good if you put in an axis coordinates to think about. Plus again, the visualization is aided by that. Right up through. Seeing that? I guess you're low enough to see it up in here, right? Well, we want to draw sort of a typical slice. You know, I have slices all the way through this object, but you know, at some height, you know, that's sort of a typical representative piece. You know, I've got then a circular disc that sits in here and has some center. You want to make the marking of the center look right. Make sure you put the one mark in the same direction as the x-axis, the other in the same direction as the y, and cross it. That'll make it look like it's in the same direction as the plane down here. Same kind of surface. Well, what are we trying to do? We're trying to set up a way to add up a whole bunch of little volumes based on this object that fill from here to here. So if I examine this thing, just kind of say to myself, what's the basic, you know, volume of this? Well, what in general, if this had a height and a radius r, you'd say that the volume is some pi r squared h. You'll notice that that's like an a of x dx kind of thing, or really, I guess, a of z. This is like that a of z, and this is like a dz. Remember the initial discussion I had? An area times a perpendicular will give you a volume. And so what? I need to set this up so that, you know, from the bottom here to the top I can have expressions for these in general. So, well, actually I'm already identifying what the dz is like the h. So this is going to end up being an integral with a dz in it. Right, and the a of z term I know is built out of this kind of pi r squared structure, so certainly pi wouldn't change. The issue is, what is r? Well, r has to be what? Described in terms of z, because z is the variable that we're working with. So we have to answer the question, you know, for a given value of z, how big is r? You know, for this value of z, how big is r? For, you know, that value of z, how big is r? We're going to have an equation that gives us that relationship. You know, looking at it here is probably not the easiest way to get that relationship, but if I say look down the x-axis at it and picture this more flattened out, I'm dealing basically with that, right, where this is the r value that I'm wondering. I know, you know, this full height is up to h. What else do I know? I know that, you know, if I'm going to talk about being at a height, I'm going to call it, what, the value z that I'm at, because I'm on the z-axis. What am I trying to do? I'm trying to write r in terms of z. Right? That's the game here. So I have a dz integral. Right now I have it as a general notion r. What? Similar triangles would probably work in here if I looked at with this little triangle here to this taller triangle. But in order to do that, right, I also need to know this distance in here. And what? If that's h and that's z, then this is h minus z. And now we should be able to go for it. So with similar triangles, what am I trying to do? I'm also trying to convert r to z. Right? So if I'm going to convert r to z, it's best to start your similar triangles and saying then r is to something, whatever is to whatever. So what r would be on the little triangle is then to say the height of the little triangle. So h less z is like what? This value. What was that value?
R.
Yeah, that's the big R, right, the one that I decided to call the radius of that cone, right, so that's the big R. So as big R is to, well, yeah, this distance in here is the big H. Right. It's the height, so there it is. And so what, that's going to say that I can replace R's with big R over big H times H less Z. Therefore what? Instead of this R squared, I have this thing squared. So I have R squared over H squared, H less Z squared. That's R squared. Yeah? See the pieces? It's kind of typical game that we play. You know, you see it in sort of generic form, and then you ask, how can I get it into the variable that we're integrating with respect to? Often a similar triangle and these sorts of little tricks make the difference. You guys seeing it okay in the back? Want me to keep it up higher, or does it need to be written bigger?
A little bigger, please.
Okay. All right. All right, so anyhow, are you okay up to this point here?
Yeah.
All right, so